So my name is Andy Cavatorta, and I want to thank Northeastern and Design Research Week for inviting me. So for me, this is part of a process where I'm developing ways of teaching the design process that makes my work possible. And it's been getting better with each iteration. So uh, my thanks to you for coming and joining. I given this twice last year at MIT and once at NYU down at ITP recently. Uh, so my a little bit about me. My studio in Brooklyn has been producing a vast array of work since 2010. And I don't have a particular field. That wasn't the plan. That's just sort of how it worked out. My commissions come from out of the blue and from around the world. I could never find my clients. They always have to find me. And these commissions are sometimes in fields that are very unfamiliar to me. And I have been working out ways to work and effectively in areas where you really don't know what you're doing. And it's not a bunch of BS. So I'll show this to you in a moment. So sometimes I joke and I say that I specialize in things that I don't know how to do. Um, these methods that I'm going to share, they don't make it easy. They aren't like a substitute for experience. They aren't something flippant, but they reveal the path forward all the way through to a fully solved design when we might otherwise be lost or clueless. So some of the different fields that I don't work in, but ended up taking commissions in anyway. I designed the world's most complex arcade game a few years ago. That wasn't really the goal. That's just how it turned out. Uh, I'd never designed a game before at all. So we'll unpack a bunch of this shortly and the methods that made it possible for me to do this. I've done set design for productions at the Royal Opera House and the Oslo Opera House, and that's such an intimidating field to enter because there's so much amazing work. The people often doing this stuff are just astoundingly skilled and talented. So for the production in Oslo, this included some physical projectors I made with tiny paper worlds inside that are set in motion and then projected onto the walls and scrims with light. So this one here is the parallax projector, but other ones use different properties of light like refraction and coherence. And yeah, this one sort of tells the story of a train journey just with 4 layers of little cut paper in motion. And I create a lot of large machines that create sound and or music. So this piece was singing its 250-year-long song at the MIT Museum. Well, I think sometime last year I took it down. I lose track. So this is all electroacoustic. I'm sorry, this is all acoustic. There's no speakers or anything. There's these corrugated plastic tubes which can be spun at different speeds, and they sing in this beautiful voice-like way. Oh, and the gravity harps were a collaboration with Bjork, who asked me for an instrument that played using gravity. She was really interested in the Foucault pendulum. And after many, many iterations of trying to figure out how to play an irregularly timed song with pendulums, we ended up with this. And luckily, these got to go to MoMA, which was fun. Here they are in the lobby. I also designed a lot of musical instruments, usually with acoustic sound sources like playing strings underwater or hives full of glass bells or using fire. Also, sometimes I teach design and problem solving at Cooper Union on and off. And I'm teaching all the workshops these days, motion control, physical sound, mechanisms and movements. But enough about me. I'm going to talk about this process here. So I call this discovery-oriented design. I have to make up names for a lot of these things, or how to invent in unexplored territory. So today I'm talking about 5 things. One is prolific prototyping and the low-low. These are methodologies. I made up these names. I didn't invent these things, but I can't find any actual use for them in common parlance. So now they are prolific prototyping and the low-low, and dual coincidence and the Irvine are projects that that were possible because of these. So we're going to unpack a bit of the development of these projects, and I'll show you how it works. And then lastly, a bit of unsolicited intergenerational advice, since I'm getting to an age where I get that. So if rapid prototyping is about spending as little time as possible prototyping. Prolific prototyping is the other way. It's about building prototypes constantly from the beginning of the project until near the end. So prolific prototyping doesn't make difficult things easier. It takes something that's impossible and brings it into the realm of what's possible. It is definitely not the path of least effort. It often produces dead ends and darlings and a lot of collateral work that gets explored that may not end up in the final. But I've found that it is often the only path that can result in a fully solved design within your finite time frame. So a lot of that is about embracing the collateral work instead of trying to avoid it. It's just faster to take it all head on. So I didn't learn any of this at MIT where I did my MS. I didn't learn it at Meta where I was a prototype engineer. I learned it here in Boston from the experienced old timers at the Museum of Science when I did exhibit development there about 20 years ago. I was in a meeting one day where I was told that we were going to have to build a rideable hovercraft, which was very exciting to me. This didn't come to me because I just wrote software back then. It went to Peter Ford, who was the right person for the job. And I went back to my desk feeling kind of jealous. And I was thinking about how I might approach this problem. And I did a lot of Googling and found a lot of research papers about the volume of air and the thrust of air and types of propellers and types of motors and the materials and the skirt that you make, how you balance it so that the air doesn't escape. I was imagining optimistically that if nothing went wrong, and I had enough budget, I could probably get something up and flying in about 40 days. I think that's very unrealistic now, looking back on it. But it was about 3 days later that Peter called me up on the phone and he said, Andy, you have to come down here and ride the hovercraft. And I was kind of stunned. So I went down there and he had basically the jankiest thing I would never have given myself permission to make. It was a giant sheet of thick plywood with some 80/20 around it with a bunch of rubberized canvas on the bottom that he had perforated with a bunch of holes. So it was kind of like an air hockey table, but upside down. And he just connected it into the shop's compressed air system that they used for running some of the tools. And he had screwed down a broken office chair, and he had two office fans in the back and a lever you could push forwards and backwards that would only turn the fans left and right. It couldn't stop, and there was nothing to say go. So we just took turns riding this thing around the workshop and crashing into things and cackling for about 30 minutes. And I went back to my desk feeling like I had just had like a semester's worth of education in how to make things when you don't know where to start. So before this prototype that he built, everything was a directionless swirl. But after this prototype, every part of it had a direction. Everything had a next step. Some parts of it worked. Some parts of it didn't work. Some were promising and they pointed in a good direction. So this is a lot about how building right at the very beginning reveals the path forward. So in my studio, I teach people that if you know what you're doing, you should start prototyping right away. And if you don't know what you're doing, you should definitely start prototyping right away because there's no faster way to get a sense for something unfamiliar than to actually start building it and making it and to start having something to play with and something to test. Somebody else told me something, this is a bit of a digression, but he was saying, the best way to learn something is to write the book on it, which is to do this full exploration as if that's your job. And so the first obstacle in a big project full of unknown unknowns is what I've come to call the speculation barrier. I had to name it because I run into this all the time. This is where your process is paused while you try to predict the outcomes of many different possible paths that are ahead of you because you're trying to avoid a lot of extra labor, which makes sense. And this can feel like progress because you're doing a lot of thinking and you may be learning a lot of stuff, but we can all get stuck here for days or weeks. And it's important to recognize when you might be at the speculation barrier and then switch modes and get some concrete data, make a test, make a prototype. If you spend time discovering a dead end, at least that's decisive. Now you're not speculating. This is like forward motion. So in prolific prototyping, the prototypes aren't early versions of a product. You're not making MVPs or minimum viable products. You're just getting answers. So I should say most of the time, I'll just go on. It's funny, I refactored all of these slides last night, so it's good seeing what's in my talk today. So I want to introduce something I call the dark forest of possibilities. And this is the space of all possible outcomes where you design in unfamiliar or uncharted territory. So you imagine a dark and unfamiliar forest. It's full of these possibilities, and you believe that there's a solved design existing somewhere in this forest. You don't really know what it is, and you don't really know what it looks like yet. You can only see down the branching paths in front of you, and you can only see down them a little way. So success in this is going to depend on finding the right paths, sort of like solving a maze, and finding your way to the successful design. And like all good journey motifs, this journey is going to change you. You end up learning a lot, your goals will evolve, and as your design comes into focus, its details might surprise you. The solutions might be things you would not have even recognized if you had met them on the road at the beginning. So discovery-oriented design is not just a way to get started, it's a way to navigate this dark forest of possibilities. The pipeline in large corporations that I'd worked at sort of looks like this, where there are all these sequential steps and it goes through a set of departments: research, ideation, engineering, prototyping, and production. And in larger companies like Meta, I saw these sad, hapless projects start off with so much hope and they get handed into a design department that does a design freeze and sends it off to various engineering departments, and they go through a process and freeze the engineering models, and then all this goes off to fabrication and testing. Um, and in the end, it's very rare for anything, no matter what kind of problems it encounters in the fabrication and the testing process, to ever come backwards, back up the chain. Pretty much everything just ends up going out into production because someone's going to be in trouble. You're going to miss your quota. You're going to not get your bonus. So sometimes when I look at these products in the world that are they've made 1 million of these and they contain some obvious flaw that everyone can see by looking at them. And I wonder how it happens. Now I've seen it. It's usually it's a decision made selfishly by a small group of people. So in discovery-oriented design, our phases are defined instead by whole generations of prototypes, like one after another. All of these processes, the research, ideation, engineering, and prototyping, they all happen concurrently and they evolve together the entire time. So obviously we're not optimizing for the least amount of work, but we are going to outproduce all the unknowns and all of the chaos that's ahead of us. It's a lot, but I think it's worth it because the maturity of your final design, I usually say, I don't know if this is true, but I say this, that the maturity of your final design is proportional to the number of meaningful iterations that you've created and evaluated on the path there. That's why I tell people when I teach them. We'll see if it's true. The second part of this is something that it's about what we choose to learn and how it expands what we're able to perceive and imagine and solve and design. For 15 years, I've been hiring people and taking in interns and mentees from so many different programs. So I sort of see the outcomes from many different styles of programs and education. The thing that I think serves people the least well is when they get taught to use a lot of tools in particular, instead of taught to think in new ways. So some subjects are like a lens through which we can see most of the world. And I found that like the most useful stuff is very universal and very low level. So like understanding geometry or color theory or optics or music theory or perceptual psychology or fundamental algorithms. So the biggest predictor of success in my studio has usually been the ability to think quantitatively. And so I end up with a lot of folks like architects and engineers who've had this background, but also sometimes designers and composers and fabricators who've had training in these areas. And the difference with them, what they're able to understand and solve, uh, uh, is just phenomenal. It's the one thing I wish I could train everybody in my studio. I don't have time to teach math because learning math, it's like piano lessons. Like you can't show somebody the facts, that you have to do it and practice it and practice it. So I know some of this stuff isn't traditionally part of the skill set for designers, but I think there's a growing place in the world for designers who can think quantitatively in patterns in networks, in geometry, in equations. And if you understand some of these low subjects, you have the foundations of many others because they're adjacent to things. This is what saves me on most of my projects. I have a background in physics and math is adjacent to everything. So you can compose better photos when you understand color theory or perception. And if you're good at basic physics, then a foray into mechanical engineering is much less of a stretch. You can already do all that math. And if you are familiar with binary and Boolean stuff from coding, then if you end up having to improvise your way through digital logic circuit, it's not like that hard because you already speak the local language. The concepts are really the hard part. The little implementation details, they're different, but it's easy to move from one field to another when you know the low-lying sort of mental languages of them. So this is what I teach people, and it's also what's made my practice possible. We'll get into some examples of how. So the first of two projects, dual coincidence. I created this for the Central Bank of Mexico, Banco de Mexico. And we can get a look at it. This is an arcade game about economics. It's a little hard. I won't go into that. There's way too much to unpack about this. Everything in here is very, very physical. The displays are all three-dimensional physical displays. The music all comes from 25 hand-cut chimes that are hanging overhead. Let's see. This is the attraction mode where it's trying to bring 5 players around the table. You know what's terrible about this? I have no good professional videos of this. I just have the videos that I shot when I was doing all this testing on site. So let's see. So I went into this with way too few constraints. They asked me that I create something to explain an economic theory called the double coincidence of desires, which is sort of an incorrect theory about how barter worked before we had money. I chose to make it a game so that we could put people inside this dynamic so they would really feel it and understand it. And I chose to make everything else really, really physical. They were very concerned about the aesthetic of the game because they were very concerned about the aesthetic of the rest of their museum, and this would be such a big piece. And so they asked me early on what the aesthetic would be like, and I sort of had to wing it. I told them that it would be like sort of a math rock musical version of 2001: A Space Odyssey, directed by David Bowie and cocaine. And so my first proposal to them involved live eels, so they weren't asking a lot of questions about the second proposal here. So where do we start? For anything that interacts with the body, I like to build a full-size maquette on the first day of prototyping. So we make it cheap, we make it fast. I call this a level 0 prototype. And here we just have some sketches of the geometry of it. So this is, of course, how you learn important things on the first day of the process rather than at the end. I also teach people in my studio that prototypes are questions. They also answer questions. And most importantly, prototypes answer questions that we hadn't yet thought to ask. Like, can we see all the play fields? How is this different if we're in a chair? Because some people will be. Is this upper part, does it feel like it's part of the game or is it too far away? What location for the buttons feels natural and how does it meet the body? And what sort of social interactions emerge as we stand around this thing? Do we look at each other? Do we want to talk to each other? I usually can't imagine this just from the drawing. And so we learned a lot from this prototype of cardboard. And the findings informed our next prototype. We now had fixed dimensions to work with, and this gives us a starting point for the dimensions of the more complex components that are going in there. So we may find an impasse to these decisions somewhere in this dark forest of possibilities, and we will have to backtrack up to this branch. But so far, no impasses are visible at this point. And about 2 months later, the other components are close enough to finished. So I've got confidence that we know the right dimensions. So we start making CAD models of the finished structure, and this will mainly be steel tubing and stainless steel plates and glass. One requirement that I have for this is that 5 people should be able to stand on the ends of this and dance without it flexing or being damaged in any way, which sounds crazy, but people are definitely going to sit on this thing and they're going to hip check it and they're going to be like groin bumping it. So all of this has to be monumentally solid. And the steel and glass were fabricated down in Mexico City by a company called Ardimu. They were my production partner down there. That's because there's no way we're building this in Brooklyn and then shipping it. It's gigantic and it weighs an astounding amount. Uh, and everything fits. I do love it when a plan comes together. Uh, and I didn't lie about the aesthetic. You can kind of see it, right? So this one is one of the really simplest examples of just iterating and iterating because we had a very straight shot. But again, we started on the very first day. We just made a big thing out of cardboard so that we could see what it feels like. So this game includes 5 pinball playfields, and I had no idea how to build a pinball machine, but I'm not too worried about that because the intelligence is going to be much more in our process and what we discover than in anything that I sort of walk into this knowing. So let's look at how we use prolific prototyping to discover how to do it. And we're going to do this over and over again until we know enough to make a final design, or that was the plan. The truth is we didn't really have enough time, but we'll get into that. We had enough to get to a good place, but I wish we had a lot more. I always wish we had more time. So the rule here is quantity over quality at the beginning. These are tests. None of these are keepers. They're all going to be rendered back out into parts and scraps. Something about each iteration needs to be correct or precise, but everything else could be made out of cheese if it had to be. Like we've got rubber bands that I found in a drawer, some coat hanger wire, some wood scraps, some drywall screws. These aren't even really pinball parts, but I'm not even really trying to make a real game the first time. We have so much to learn about mounting and powering these assemblies that are going in here and the basics of making a playfield. So this playfield is going to get destroyed. What we are building here mostly is our own experience and our own understanding of it. And we're going to take that into the next phase. So playfield number 2, again, we're going to play this one. And for now, I'm just drawing the game on some scrap plywood. That's our level of precision because I don't know how to get all of the proportions right yet. I really wanted to at this point, but it was beyond my reach. So I'm not spending time on it. And we still have so many other things to learn. So it's true that there's no substitute for experience, but it's possible on a path like this to get sort of concentrated experience by building iterations over and over again and playing and testing them. So again, like I say, this is my first arcade game, but we built it over and over. So it's not really exactly the first. It's the end of quite an intense process. So we take our playfield board and we're going to drill it out and make and mount the parts and design the circuits and wire them up and design the logic and the code and get it working and troubleshoot the whole stack. And then it's time to play it. Noah, you got the circuit boards all running?
Yep.
It's a bit of a jungle under there. A little more over here. More over here. Big stack of software. Everything's a mess, but it's fine. And gonna multi-ball it. You go ahead. So a lot of things about this don't work. That's okay. Really, we're just getting a lot of the software. It's our first time getting all of the sort of layers and layers of the technology working. And I'm still figuring out what the correct angle is. The angle always feels wrong, the motion of the ball, no matter how I do it. So from this prototype, I learned that a good game is about sequences of shots. And I really want to go play pinball at this point to learn more, but it's the middle of the pandemic and there's nowhere to go. So I'm drawing and imagining how a playfield might be laid out for sequences of shots where the ball never just goes thunk. It always goes somewhere and it always does something. It stays in motion. Again, this is very speculative, and I spend a lot of time speculating and realize that I'm doing that thing and I have to stop and we just have to make the next one. So for the next round, we're knocking these out in a little over a week at this point. So the games are getting more complex, but we are accumulating knowledge and techniques. So we're getting a lot faster and it's kind of evening out. That's good because we do not have much time. And I'm still using rubber bands and bent scraps of aluminum, but the new one's kind of pretty. So I'm starting to take pictures of these. And this one isn't a good game. I was hoping it would be, but I didn't tell Rachel. All it really needs to do is point the way to what a good game will be. We even brought in a guy who's a competitive pinball player to give us his feedback, which was honest, but super useful. And at this point, we're basically running out of time. We've got about 4 months to make this thing from end to end. So more Blackboard sketches for yet another iteration. And my last playfield prototype is super basic.
Nice.
On request. Huh.
So I really could have used 10 iterations instead of 5, but that would have been another 2 months, and we just don't have the time. Everything in here works well together. There isn't much there, but there's going to be a lot of other lights, and a lot of other components are going in here because of the multiplayer stuff. So we have to stick a fork in it and move forward, and we really do have to get a wiggle on at this point, because the final build is going to be sort of a beast. Now that we've verified our playfield details by playing them in real life, we can start working confidently in CAD. But so many layers and so many fasteners. This is my first CAD project, actually. It ended up being this one. I couldn't hire my regular CAD person during the pandemic. So our playfields are made of these big slabs of aluminum. And the result is beautiful, and it's technically terrible because they're full of short circuits and arcs and things like that. And the machine has over 900 individual channels of lighting. And so as I was showing you earlier, this is the attraction mode that it performs between games. The museum's fairly calm, so I wanted its attraction mode to be fairly calm. And so a little bit just about the Lolo in this case. It shows up everywhere in this process, in the circuits, in the code, and in the physics of it, but I'll give a couple examples. The first one is just the code. The machine contains 17 Raspberry Pi computers. We mostly interact with them through SSH and Bash and Python. But the central control computer serves up a GUI for troubleshooting and administration. And this GUI is all written in just raw JavaScript without any frameworks and without any includes, just dynamically rendered SVG front end made with raw JavaScript and the SVG bindings to the document object model. So when I was learning to write interfaces, I don't know, 20 years ago, 15 years ago, jQuery was what everybody was using. And if I'd invested in that, then everything would have been obsolete by now. But by going super low and interacting just directly with the definitions of the language and the definitions of SVG, the code that we wrote for this, the code I wrote 20 years ago to do this is as fresh today as the day that I wrote it. Also, something that's very freeing about working really, really low is you can do anything that can be done in a browser. You're not stuck with what a particular framework does or what it expects you to make with it. Since we're never making anything normal, that really helps. And here's a little physics example of the Lolo. And the center of the game is a machine called the exchange matrix, and it passes balls between the playfields through a series of carousels. This all represents trade. So we need to eject these balls from these tubes one at a time. And we kept adding more power, and we got the punchiest solenoid actuator we could buy, and we ganged up several power supplies, and we had enough capacitors to stun an aux. But it's still all just kind of sloshed around like this. But luckily, my friend Noah here also has a background in physics, and we were like, this isn't really an electronics problem. This is a physics problem. And we figured out a way to just have one ball at the bottom bounce back and impart all of its energy to the whole stack at once, which would travel up as a big wave. And when that wave of kinetic energy got to the top ball, that ball couldn't hand it off to anything else, and it would fly off. You've seen this like when people play croquet, and they have to play through. So when this finally worked, I did this for about a half hour because it was so satisfying. You can see, not just yet, well, you can see how janky the setup is. I just have some 2x4s and a bowl and a bunch of things taped down. I'm just tapping a wire to a contact over there. But it doesn't need anything more than this. It's mostly about moving these balls one at a time off of a stack. And everything together now. Into the pocket. Back out of the pocket into the stack. Aha. These very mundane things become a good day when you've been really worried about whether you're going to make something work. And then here at the end, just a little video of this thing doing its inventory routine. When you first power it up, it doesn't know where all the balls are, and it kind of has to shuffle them around to count them. So that's what we're seeing here. And I know that there's an optimal algorithm for getting all of these to work at the same time. I spent so much time with it in pencil and paper, but I think this one was beyond me. So that's enough for that first project. The second project I want to talk about is a little bit different. So the Irvine is a crystal-based electrophone, an electronic musical instrument. So this is my first electronic musical instrument, and I share it here because the fossil record for the development of this is pretty complete. Oh, we'll come back to this video later. So this was a contract from the Liszt family in Graz in Austria, who I had sort of met in passing. They're sort of like the king and queen of Graz, as far as I can tell. And they're huge fans of music. And so for the 80th birthday of their brilliant patriarch, Herr Dr. Professor Helmut Liszt, they asked me to create music using special crystals that were developed by AVL, which is the Liszt family's R&D company. AVL was the first to synthesize gallium phosphate. It's a lot like quartz, except it's super tough. It can take a lot of pressure and heat, so it's really good for industrial sensors. And they asked me to figure out how to make some music with it. So I chose to make an electronic musical instrument for this. And it must have an all analog signal path running from the crystals and ending up to the sound coming out the speakers. There were sort of a bunch of ways to fake this up where you could do mapping things and you could read the, I didn't want to do any of that. I wanted the sound that we hear to have originated continuously all the way back at these crystals. So I didn't have enough constraints, and sometimes I do this. When I don't have enough, I just make up some constraints because it makes life easier. And as you know, constraints, if it's your first project, you don't understand how constraints make the process better. But if it's your 10th one, like it's become pretty obvious. So this instrument is meant to be an orchestral electrophone from a reimagined timeline in which electrophones made it into the symphony orchestra. They only missed it by about 10 years. So it has no automatic music features like no arpeggiator or standard synthesizer things, and it ignores the whole menagerie of standard electronic synthesizer circuits like low frequency oscillators and voltage controlled filters and all that stuff. And instead, it's just sort of conceptually built up from first principles of acoustics that were outlined by Hermann Helmholtz in the mid-1800s. Helmholtz shows up everywhere. He wrote an enormous book called On the Sensations of Tone, in which he quantified everything about sound and music and voices and the anatomy of the ear. It's kind of amazing. So I'm going to go really quickly through all these weird controls. My instinct is always to make yet another one of these everything machine interfaces that promises every expressive dimension, like strumming and picking and chording and sort of legato and staccato sounds and glissando, gliding between pitches, key dynamics, and the ability to bend each note like you could on a guitar. But every few years, somebody makes one of these interfaces, and I've never heard anybody play any music on these that I want to hear. I hope I'm not insulting anybody. Maybe there's good music on them, but I've never found any. So the constraints, I think, matter in the instruments just as much as they do in art and design. So I'm going to make something thoughtfully weird, inspired by electronic music instruments from about a century ago. So there's a 48-key monophonic keyboard. You can just play one note at a time. It's a sort of capacitive touch keyboard. And there's this big slider in the front that slides up and down 4 octaves. And the keyboard and that pitch slider from the previous slides, they control the pitch of these 3 voices that it has. And so these voice keys control the separate volumes of the three different voices. So there's silence until you start pushing these down, and the further you push them, the louder it is. So it sounds very sort of moop meep on its own when you play it. Um, and then there's a lot of controls for the timbre or the tone of each voice. So using the three different tones, you can sort of form some things that are a bit like words. So in a very long, if you play the cello, you can change the tone of a single note over the course of the course of playing it. And I wanted to have that kind of sensitivity. And I did add the sort of 3-channel sort of looping feature like a tape loop. I didn't want to put anything automatic in it, but I stuck this into one of the prototypes and it was so much fun. I decided to break the original rule. And let's see. And there are some filter options here at the end. So we ended up with this kind of design at the end, but we started here. This is our level 0 prototype. We made it in the first few days in my studio. I do teach people that all early prototypes should look like they were assembled at gunpoint. We're really just getting some quick answers here. Once again, I wanted to know what it's like to try to play music with a sort of capacitive interface and these little strips of copper. Like, does it produce weird, spurious things? Do you have to be careful about how high you hold your fingers to not accidentally trigger stuff? As you slide back and forth, does it sound right? Does it feel right? Does it feel connected? You know, all these sort of things that are a little hard to quantify. You just have to build one and try it out. And here's my first report back to the King and Queen of Graz, the Liszt family, about how this is going. So we have down here, we have these 3 mechanisms. Again, just made out of scrap wood. And they're really just parts of these keys. These control the 3 voices. And over here we have the glissando slider, made out of stuff from around my studio. And in here, we have all of the electronics that's actually making all of the work happen. And so anyway, so that's our level 0 prototype, sort of built out a little bit. I wanted to know if when we play with this stuff, like, you know, as designers, sometimes your first question when you're starting a project might be like, am I delusional for thinking this is actually going to work well? And sometimes the answer is yes. And then your next question is, can I keep my delusion and still succeed somehow? So that's kind of where we were with this. And I think, yes, it was a little bit delusional. It's a little too complex. It feels weird to play it, but I really want to keep our delusion and move forward. So if there is a solution, we are going to find it somewhere down here in the dark forest of possibilities when we go exploring. So I'd forgotten all about this prototype until I found a picture of it. I can see what I'm doing here with the keyboard. There are little tactile lines in between these keys so that when you're not looking at it, you can feel the distance. If you play piano, you know what an octave feels like under your fingers when you slide. And these little metal dots in here are the keys. They're tiny. I don't know what I was thinking. They're like, they're made out of brass and copper, and they're laid out in the same pattern that you would have the black and white keys of the piano. So the idea is you could look at the color pattern and use that to navigate. It turns out this actually doesn't work well at all. It's not nearly enough. So total failure. And there's this ring to put your finger in for the slider, and the ring feels pretty annoying in my opinion. So prototype 3 here is starting to look legit. We've got this new fingerboard with these longer keys on it, and it's so much more visible. And this new like yoke for the finger, it's just a piece of zip tie and a spring. That's actually the most comfortable version so far. And the new voice keys are an improvement over the old ones. And we're testing this version with professional musicians and getting their feedback.
I'd really like to have those
I think it's still annoying to play this thing.
Where you get to, oh, listen to this.
So prototype 4, we're moving into. This one is all about new ideas and testing and collecting. We're testing and collecting data about the finger spacing. And these questions are solved for the piano, but for the capacitive fingerboard, it doesn't work like a piano keyboard, and it's not laid out like one. So we aren't really going to make a lot of assumptions. So we're measuring the span of people's hands. So the narrower the keys are, the more keys you can get under each hand, and the wider you can make chords and stuff. But the narrower they are, the harder it is to play quickly with precision. So there's this trade-off. Oh, and we have new finger yolks here for testing. I'd say guess which one of these is the best, but that's a trick question. They're all terrible. Every one of them is the worst. And we also tested glass circuit boards for this design. I thought they were going to be very beautiful. But once we started to build little versions of this, I realized they were going to break in transit. They were going to be impossible to repair when they were broken. And so conclusion for prototype 4 is everything is horrible, but that's decisive. So we're going back up the path in this dark forest of possibilities to where we branched off to get into all of this. And so now we're going pretty quickly, but the machine's getting complex and we're starting to cat it up. So we've traded out this finger yoke for just a slider knob that you can touch or not touch, depending upon whether you want to. And so the right hand is now free to go and adjust various knobs and sliders while performing and to change up the voices. And prototype 5, we're trying this one more time with the fingerboard, and I'm still just drawing on wood with Sharpies at this point. But our fingerboard now has these tactile clues and color clues and some shapes, and we're evaluating these organ drawbars for setting the timbres. I love these things, but it turns out for engineering reasons, they didn't really work out. But they have detents and they have numbers. It's very easy to make a bunch of settings and then write them for them. You don't have to look at them too hard when you're working with them. So again, we've got another version, this whole thing, including all of these electronics and all of this code inside of it, it's still all disposable. But we're accumulating ideas and parts that are keepers, and they'll all go into the next iteration. And so it's not really working yet, but we have to play with it as much as possible. And here's my friend Merche Blasco, who's come over just to poke around with it. Tell us what she thinks. That knob doesn't work, Merche. There we go. And so I was really hoping here that prototype 6 would be the keeper, the final prototype. So everything has been rebuilt and everything's been sort of re-envisioned and iterated, including these timbre controls and a new slider and a new keyboard and a new aluminum voice keys. And now we have these staccato buttons that people had requested. If you push them down, now the keys don't go wah, wah, they go bop, bop, bop to make like a very hard edge on each note. A lot of making a good instrument is not so much about the tone or the timbre of it, but in how it allows you to shape notes and the spaces between the notes. So I'm still just making up processes here. This is how we're figuring out the wiring. It's faster than trying to do the wiring in CAD. It's visible to everyone at all times, and it's really fast to update. You just cut a new piece of paper and tape it in here. So we have a terrible problem where we have so many types of electricity running around in here, so many signals that they're kind of interfering with one another, where the power systems are interfering with the sensors and the Ethernet noises are showing up in the musical signal that we can hear. And so we've been trying to like design a super nice, perfectly laid out set of wiring for this. And I don't know if you're familiar with the sort of idea of what they call cable porn on Reddit, which is these photos of perfect and precise cabling, and it's very calming to see it all done super professionally. So we don't seem to be able to do that in my studio. We can only make like cable gore. It's like distressing to look at. I swear this one is haunted. We started off with everything organized, but it just gets worse and worse as we keep working on it. There's so much electromagnetic crosstalk in here. I think it can practically sing by itself if we just left it alone. And so finally, prototype 7 is supposed to be the final version, and we made it. We're about 8 or 9 months in, and I'll show you just a bit of this final process. So you can see it actually ends up requiring quite a bit still in the prolific prototyping process. So this top plate here, we ended up making it out of some technical foam because I broke my CNC machine while trying to sort of hog out this giant slab of aluminum to make a perfect top for this, but you'll see. So I just started off with some modeling clay because I didn't know how to put this into words and I did not have a modeling program. I was just trying to get the general shape for this. And I'm still just making up processes. We sliced up the model and we turned these little slices on their sides and then we measured the profiles. And then we made a clean and accurate CAD model from all of this to try to figure out what this big top playing surface was going to be like. I did at one point really want to do a 3D printed porcelain top for this because it would reference a lot of things in Austria where it was headed, but that was going to break in transit at some point. And I realized that when you knocked on it, unfortunately, it was going to sound like the lid of a toilet and nobody would say it, but everybody would know it. So you have to be careful about bringing in unintended associations. So for the fingerboard, I'm switching from all these small incremental changes and I'm just kind of using the big hammer now. I'm making everything as obvious as I possibly can. So we're now cutting these extra large size keys out of brass and copper. And we're cutting all of these just by hand from stock. No CNC machine now, and we're finishing them up by hand. And then we're using a 10-ton press to stamp letters into each one of them. So now it doesn't matter if you play piano or not, you know which one is the D. It says D on it. And we solder contacts and wires to the bottom of these, and we press fit them into the fingerboard here with a little bit of help from a mallet. So since there's no CNC machine, these big aluminum slabs are just getting finished by hand. You can see how rough they are. So I don't really enjoy this process of doing them by hand, but this is the path forward. I'm glad that we have a path forward because we always have deadlines. So I think perhaps I should mention that a little bit more. These aren't just sort of open-ended explorations that will be done when they've got delivery dates on them. They always do. And so always I'm proposing a thing I had no idea how to create, but we have a fixed delivery date for it. So makes things puts a little hustle into everything. So there's a new button under the thumb, and it's a hold button. So when it's pushed, it holds all the current values of these keys. So now your left hand can come up to do other things and play. And the final results are worth it. So in prototype 8, we rebuilt all the electronic circuits with somebody instead of me designing an Austrian engineer who is incredibly fastidious about everything. And a happy accident in here. The sort of huge forehead on the top plate here is perfect for holding sheet music. I didn't plan it that way, but it was sort of a lucky outcome. And it's currently being used by various composers in Austria and sometimes in Germany and sort of getting passed around amongst the many big contacts of the Liszt family. Here's Rupert Huber, a composer, making a very minimal piece. But setting up layers and layers of sound and tones. And so in 10 months, we went from this thing on the left where I have no idea what we're doing or how we're going to make it. And I could not have pictured this final piece on the right at the very beginning because it had to be discovered along the way. Boy, now I got to go into one here that is. I was going through these new slides. This very last section here, I'm going to go through it a little quickly because I think that we go into a little too much technical detail. And we also go into some very fun little digressions about explaining some of these concepts in music and sound. So we'll spend time on the digressions, but I'm going to hustle through a lot of these like crazy looking diagrams. But the fundamental part of this is I took a lot of concepts from acoustics, from how sound works and how waves work in physics. And I used these as the starting point for how we would make all these circuits work. Because the signals, they're very much like waves. And when you add them up, they're like waves. They do the same sort of superposition of waves and you get beat frequencies and stuff like that. So the crystals that we're using are they run at around 6 million cycles per second. It's way, way, way higher than anything we can hear. So we end up putting them through this sort of process called heterodyning, where you take two of them and you combine their signals, and they produce an output signal, wah, 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 with like these big sort of throbs in it that are equal to the frequency of that is equal to the difference in the frequency between the two that you put in. So we were trying to do everything to modify, to control the frequencies of these crystals right at the origin of them. But I gave up on this because everything was way too slow and way too imprecise, and it just felt like chaos. Though at one point we were experimenting with doing this.
Okay.
Really?
He said so.
We were trying to do this thermally, and luckily we happened to have a big bunch of liquid nitrogen around.
All right. So you're going to have to capture and collect the data about that, the frequencies.
So again, like I was saying, many full explorations that don't end up in the final product. Although you do end up with a lot of fun videos.
Super.
Yeah.
That's amazing.
And so when you combine two signals, you end up with this big sort of what they call a beat frequency, which is equal to the difference between the two signals. And then you can run them through a filter and get just the beat frequency out. It's how you can take very high frequencies and turn them into much lower frequencies by combining them. And so we need to get audible tones out of this. And so I'm going to have to talk a little bit here about harmonics. So we're going to run it through one more of these processes to bring it down to the range of, well, where we can hear. And we're also going to add a lot of texture to it at this point. So I don't know if people, do you have musicians in the room? People, yeah. You walked in and I was like, that guy's going to want to talk about music. It's like, there's a term in music called timbre. And timbre is really like the flavor or the tone of an instrument. It's why when you play a C on a piano and play it on a saxophone, they don't sound the same, because sounds are complicated and they bring with them all sorts of extra tones on top of them. There's more to it than we usually acknowledge. So timbre is only negatively defined in most places. The ANSI definition for timbre is the properties of sound which are not loudness nor pitch. So that's, I like negative definitions. So most of timbre comes from harmonics. The sounds we hear rarely have just a single frequency. We live in a complexly vibrating world, and most physical sounds have extra higher frequencies that come from the resonance or the materials or from standing waves. And there's a perfect model of this in which they're all integer multiples of the fundamental tone. So if you had a bell that was like 110 hertz, it would have harmonics at 220 and 330 and 440. That's called the harmonic series. But most of the world isn't that simple, and the harmonics for most things are very complex. Some of them are missing. Sometimes you have extra weird ones. Most of them are a little bit sharp and flat. This is the harmonic series. You've heard it. You hear bits of it when the wind is blowing over a wire somewhere and it's whistling, when it's changing pitch, and you hear it in the way the bus brakes squeal and the pitch goes up and down. And oftentimes you hear all these sounds stacked up on top of each other. So, and here we see how the prototype itself generates these sounds. I don't know if I'll spend time on this. First of all, we set the speed of the horsehair bow and set it in motion. During the pandemic, for a client, I ended up making a device that would explore harmonics on long strings. This is my little phone video for them. Kind of slowly, so that the horsehair comes in contact with the string itself. And yes, I'm building big robotic things with horsehair in them. Oh, that's a bit too much. We're going to back it up just a little bit. And now we will change the pitch using the finger slider. This mechanism makes a little bit of noise, but that's just because it's a prototype. The final version won't. So here you see the smooth action of the slider, changing the effective length of the string. Right now it's creating a nice long slow glissando down to its lowest position. Next, we're going to take a look at the bow position mechanism. The largest effect on the timbre comes from the position of the bow. And so here are some recordings that I took all with the same pitch. And when you hear just one of them, you mostly hear the fundamental pitch. But when you hear them next to each other, you can clearly hear all of the extra harmonics that make up their timbre. This is all, I showed you a picture of that machine because this is the machine I used to make these recordings. And I like this one where this is just the bow in different positions. And you hear different harmonics sticking out. Anyway, so for our second stage, we ended up needing to create all sorts of electronics that would mimic how this works. And this is just my fanciful illustration of how we get our main pitches and our harmonics. And then our last little bit here was a piece that didn't make it in, but it was so fun, I have to talk about it anyway. So there's something called vowel formants. So when you sing an ah and an ooh at the same pitch, like why do they sound different when they're the same pitch? So human voices produce not just like a simple frequency, they produce this huge range of sounds all at once, and they're pretty unique to us. It's why our voices are unique and recognizable. Like when you hear somebody laughing or coughing and you recognize their voice, this all comes from vowel formants. It's what makes your voice your voice. There are sort of hot spots where certain frequencies are amplified because of how they resonate in your sinuses and in your mouth, under your tongue, in the back of your throat, and in your throat. It's all very physiological. You can't do much to change them. People with powerful voices have what they call singer's formant, and there's also an actor's formant with a voice that sort of cuts through when they speak. So this illustration, again, comes from Hermann von Helmholtz, who figured out how to put numbers on all of these things that previously had just been sort of like subjective things in the realm of the spirit, music and how it feels and what it means. He was also making these additive synthesizers back in the 1800s to explore vowel formants. And then lastly, on this subject, here's Homer Dudley's wonderful voder demo from 1939. I think the woman here who is operating the voder is the real star of the show. But
uses only two sounds produced electrically. One of these represents the breath. The other, the vibration of the vocal cords. There are no phonograph records or anything of that sort. Only electrical circuits such as are used in telephone practice. Let's see how you put expression into a sentence. Say, she saw me, with no expression. She saw me. Now say it in answer to these questions. Who saw you? She saw me. Whom did she see? She saw me. Did she see you or hear you? She saw me.
And then one last little bit, I guess. Yeah, one last little thing just about vowel formants. I put this in because it's a fun exercise. We usually have in our voices like 3 or 4 hot spots or sort of diminished spots at any given time that are most pronounced. The biggest one, the most influential one, sort of disappears when you whisper And now you're mostly hearing the second and third and fourth formants in your voice, and you won't know them unless you hear them next to each other when you change one. So if you whisper these words to yourself, you'll hear the dropping frequency of the second vowel formant in your own voice. So I don't know, you can try it. Heat, hit, head, had, hot, hot, would, would. Anyway, I love learning about all these things on every project. I didn't really ever have to know about vowel formants before I was trying to put them into this instrument. And here's our final signal paths for everything, and a nice map of illustration of how the whole thing works. And that kind of wraps it up for this. And I'm just going to say a little bit here at the end about what you need. So this whole process, it's easy to say it. It's not that easy to do it, especially because a lot of this fast prototyping requires having what you need on hand. And that's really hard at the beginning. I started out building this stuff like in my kitchen, where I think I had some pliers and I had a screwdriver and a bunch of ideas. So you need to start somewhere. You'll need tools, and you buy them as you need them. You have permission to buy cheap tools, replace them if they're not good enough, because the cheap ones are usually really cheap. And they all accumulate. And I usually buy extra parts when I'm ordering things, just because time is of the essence and you might break things and having to stop and reorder. I do a lot of overnight shipping, crazy deadlines. So I end up with a studio full of the extra parts left over from each project, and it's wonderful to have them around because they tend to be largely useful things. And it will save you time, and then when you go to make stuff, you just have stuff. And this sounds mundane, but a lot of scrap materials, cardboard, wood, glass, kind of everything, and you can hoard it. And if you can find a way to organize all these things, please share it with me, because I've been trying for years. I have everything else organized in my studio, but the scrap materials defy classification at all times. What else you need? Sort of the right people. Don't do discovery-oriented design alone, because it's a massive amount of work and you get blocked all the time. And that means everything when you work alone is in the critical path, every single task. So whenever you get delayed or stuck on one thing, you can feel everything else backing up in the project, bumping up against your deadline. If you do this with 2 or 3 other people, it's not so bad. Everything's moving forward, no matter who's stuck. And then something that I call the dark energy, which is discovery-oriented design takes a lot of mental and physical energy, and the right kind of people are really energized by the process, and they like thinking about this stuff. It's much more interesting than what they've done in offices or in regular jobs. So when I'm in project mode, I'm thinking and imagining and solving like in the shower, or when I'm biking in traffic, or when I wake up in the middle of the night. And I do like working with people who are really fascinated. They've been given parts of this project and they're thinking of things, and they show up in the morning with new ideas and new things solved. I say that this is dark because you can't really measure it as an employer. It's like the sort of thing that happens outside of your studio. And also a little bit about the shape of attention. I hire people sometimes for the shape of their attention. And the idea is what you can do with your attention is what you can do with your brain. So some people are like laser beams. This person, my best assistant ever, they can do minute details perfectly all day long. It doesn't bother them. I can't do that. Some people's minds flow smoothly, or like water around all sides of a problem. Some people are really good at zooming in and out. They can hold the big picture and all the intentions of the project and see all the microscopic details at the same time. So I make a terrible laser beam. I'm sort of like 12 caffeinated horses that can be induced to run in the same direction when things are interesting. So that's good because I'm a multitasker, and it's good for me to run a studio and keep everybody else running. So it's great to have a big diversity of types of attention. And then quantitative thinking. I'll say it again. The most potent skills, I think, for discovery-oriented design are the ability to think quantitatively in networks, in geometry and shapes and patterns, and to turn things into equations. So you can turn things into math, solve the problem, solve the math, and then solve the problem. Also, to state the obvious, find smart, creative people who are consistently calm and kinder than necessary, because this work can get really grueling and stressful. And doing it with the right people makes your studio feel less like an emergency zone and more like a pirate ship on an adventure together. Uh, and a couple of things here at the end to be emotionally prepared. I usually give this talk to a lot of students, so I know like more experienced designers don't need to hear this. The imposter syndrome might not ever go away, and that's fine. You have it at the beginning of your career when you're new at everything and you don't really know what you're doing. And sort of in the middle, I remember not really having it. I know how to do my job and I know how to do the other jobs that I've done, and I can do a little more than that. But if you push out beyond that, kind of into some unexplored territory, you always don't know what you're doing. And I realized that the people whose work I really loved, a lot of them don't know what they're doing either. And they feel this all the time. And it's totally fine. So it was good to just tell myself that it's not a sign that there's anything wrong. That's just what it feels like. Uh, Also, the work may never get easier, but your work definitely gets better. And as you get better at it, it can be more gratifying. It can still take a lot out of you, but I think doing good work is a lot more fun. And that's everything. Boy, you sat through it all. Thank you. Now, that doesn't leave us a ton of time for Q&A, but I might as well. If anyone has any questions, I feel like I've said everything I know.
Hi, Andy. Thanks so much for this. Really liked it. I have three questions that build upon each other, and you um, adhered to it in the last section on what you need, or like answered it. But the first one is you do a lot of prototypes. So I was wondering, do you recycle your materials when you do the different prototypes? If you're using like make a prototype and then do you disassemble it, it becomes scrap, and you do something else?
Yeah.
Yes. Okay. So yeah, because I was running a pilot session for one of the something that I'm making, and I found myself printing a lot of papers, and I was like, okay, this feels a bit of like I'm doing this for the learning process, but there's all this material that I've made, and so I'm just curious about how you recycle material through your different prototype processes, which you haven't answered. And then you can, I'll just say the other two, and maybe you can answer them all together. The second one was you talked about team. I was curious what kind of expertise and backgrounds you sort of like build your team with, because you do say how you brought in like a person who does CAD specifically for some projects, but your projects are also specific to what you need. And so do you have like a constant base of folks that you have, and then you also hire people for the specific projects? And so curious about how you've like made up the team in terms of different expertise. And the last one is, I noticed that you're based in Brooklyn, and I have over time come to see that like it's a sense of like artistic hub. So I'm just curious about what brought you to Brooklyn to be the home base for your studio.
Oh boy. Well, the first one about hiring people, I sort of always have to explain this, that my studio doesn't have employees, my projects have employees. So it's all just sort of based for maybe 6 months or 14 months or however long it's going to take. And yes, there is a fixed set of people who've been wonderful to work with. And if I can get them, I always will. But sometimes I have to take other people's recommendations for folks I haven't worked with before. Also for interns, a lot of the local universities are aware of me. So when their students will end up reaching out and asking me for internships. And also there's some mentoring programs here and there. Uh, like New Ink has a mentoring program, and I think I'm about to take my third mentee from New Ink. Uh, and there was one woman, Leah Mice, who came over from London and introduced herself and then said she was doing a residency in my studio. And I was like, okay, we can do that. So there's a lot of sort of formal and informal employment happening there in my studio. And I'm sorry, what brought me to Brooklyn? I originally moved to New York when I was 17, the day after I graduated high school. I just wanted to get out of the town I lived in. The town was fine, but you know how it is. Sometimes you want to get away. And so New York has always really felt a bit like my home. I came back here to Boston to go to grad school and to do a bunch of other things with for about 13 years I was here. And then I moved back to Brooklyn because Bjork told me to. Uh, I was working with her on a project and she said it had to happen in Brooklyn and I had. So she's the queen of the universe, and so you have to do what she says. Anyway, no regrets because I was intending to move back to Brooklyn eventually anyway. It, yeah, everyone says it changes a lot. It always does. But it's, I think there are people who mostly feel comfortable there more than anywhere else in the world. So I'm one of them.
Hi, Andy. Thank you so much for this presentation. It was like very delightful to listen to.
Oh, good.
I'm wondering one thing. You said that like you made a lot of like prototypes, and I'm sure it took like a lot of time. And how was your like testing sessions? Like how many people did you test it, or like what was your what was you were looking for in your like the target audience or in your test?
Oh, well, for this one with this instrument, I was bringing in a lot of musicians and arrangers. Luckily, I'm a little bit connected in New York with a lot of music people. So I could bring them in and just, it was very open-ended. I was asking them how it felt. There were a lot of, trying to think. I remember for different things, I'd have specific things I wanted to know about. Like, can you play this keyboard? Do you know where your fingers are when you play it? Or does it make sense? Should these keys be on the right side? So it's more like playing guitar, or should they be on the left, like an Aunt Martineau, which is a beautiful electronic instrument from 100 years ago? So really a lot of more open-ended questions and wanting to know people's experiences with these things. I think part of this, it's different from what happens, I think, in a lot of corporate testing, because there aren't any layers here. It's just me. I'm the person who's going to make all the next design decisions. So I can have a much more open-ended conversation with people.
And also, what about the arcade game? Like, did you only test it with like the gamers or?
Oh yeah, I only tested it with a few people. It was the middle of the pandemic and the really bad day. I think 800 people a day were dying there. So it was a little hard to get people to come in.
I see, yeah.
Yeah.
Thank you so much.
Oh, you're welcome.
I appreciate it.
Thank you very much. Very interesting. You receive commission. You are commissioned, so you work for people.
Yes.
How can you explain this process? Because I guess some customers can be surprised, even though they come to you because they know, I guess, your way of working. So how can you explain this?
Oh, well,
process?
I often don't explain it to the clients. Oftentimes, they like previous work that I've done, and they would like me to come and do something for them. Sometimes it's something very specific, or they have specific parts of it, like make music with this crystal, or I want you to make something that explains this economic concept, or things like that. Sometimes I get too few constraints. Like you saw in here, I have to make some up because you need them. Oftentimes with the clients, I don't work by the hour. I don't do anything like that. Usually we have a delivery date and we have a budget, and they have some idea about what I'm doing. And under the best circumstances, they're local and they can just drop by the studio whenever they want. My favorite client experience was working with, well, it was an ad agency between me and the client, but one of the people at the agency worked or lived in the neighborhood, and he would stop by 2 nights a week. And we would make him cocktails, and we were teaching him how to solder. And he would basically just hang out with us as we worked late into the night on this project. And it was very peaceful because the folks who were the clients, they knew exactly what was happening. I love that kind of transparency. Anyway, that's generally how I work with folks is we have a bunch of big outlines and they don't micromanage what I do.
I'm sorry I missed the first part of your presentation, so maybe you discuss something about this. I saw a lot of mechanical parts, a lot of electronics. What about software and DSP? Is it a big part of your work?
Software is a huge part of my work, but I don't want people to think about that when they look at it. My strongest skill in all of this technically is writing software. So I was a professional software engineer for, well, a long, long time. And I think it's because when I was a kid, let's say in the 80s, anything involving computers looked really, really magical. And now nothing looks less magical to me. So all of the technology stuff, I sort of want to hide it. Even with that pinball game, with that 5-way game, I originally started out with displays, video displays overhead. And I just didn't want to see any computers in there because it was less magical than making a physical 3-dimensional display. Uh, so yes, lots and lots. I have a large stack of software that I've developed for my studio just for prototyping with the idea that everything can just get a computer on it. I use Raspberry Pis and I'll usually use a dozen or 2 dozen in a project. So everything just gets its own little local computation and they're all connected on a network. And then there's one central controller. It actually has been very, it's made a lot of things extremely sane, which is good. And
Can I?
oh yes, please.
I'm Paolo. Great presentation. I love. I'm not a musician, but I love music and yeah. So and design combined. That's great. Sorry for the kind of trivial question, but how does it work with clients? You know, how people get to you, how you get your projects funded.
Oh, yeah,
Because
I'm still figuring that out 15 years into this. Right out of grad school at MIT, I met Bjork while I was there, and then I did a project with her that was pretty visible. And that visibility helped me. People were joking when I'd hear from folks for a little while from ad agencies. They were coming to me. I wasn't showing anything related to ad agencies, but people would come funding different kinds of work for their clients. And they were saying, you know, we have your stuff here with Bjork in all of our mood boards. So we figure we might as well just come and talk to you. Largely, I found I have to stay very visible. I have to go out and give a lot of talks and I have to put videos on the internet. And I have to put up works. The thing that usually doesn't get me leads is putting works in a museum or in a gallery. That's where they get seen the most in person. But largely it's speaking, putting videos up, and just chatting with people, going to events where there'll be folks who are interested in this kind of thing. So I always say I could never find my clients. They always have to find me, but I always have to stay visible so they can find me. I'm not very good at self-promotion, as it turns out. I don't like telling anybody that I'm good or my work is good. I just want them to see it and like it.
Do you feel yourself part of the art?
Well, that's the idea. Years ago, I started saying, well, I asked at the very beginning a friend of mine who had more experience than me if I should be a designer or an artist. And she said, clearly you're doing both, but you should call yourself an artist because then people will pay you for the idea instead of asking them to execute their idea. And that's been kind of true. So I thought that turned out to be good advice. They also said that when you're a designer, people don't respect you as much, even though you do the same work. They treat you like work for hire. So your name doesn't go on the piece. They just hired you as a function for their project instead of it being your project. Anyway, I sort of founded my studio in the first place because I didn't want to be bounded. I wanted to make the best work I could possibly make. And I wanted to do that over and over again, to be kind of right up against whatever my limitations are. It's a terrible reason to run a studio if you want to make a lot of money. But it does produce a lot of gratifying work.
Thank you. Anybody have?
We talked about recycling, and as we discussed earlier privately, I live in Boston and New York, and freecycle.org is a wonderful organization, both in New York City and Boston, for asking for things you want or giving away things you don't want. So have you used that organization?
I usually don't, but I have 2 people in my studio who use it quite a bit, and they will procure a lot of things. Usually I don't feel like I have the time. When I'm building stuff, I used to do a lot of sort of dumpster diving, and I would pick up a lot of materials and sensors and motors and stuff like that. But once I started doing this very quickly and professionally, I realized there's very little alignment between the random things that I can find and the thing I actually specifically need right now. So I didn't talk too much about it. There's a bit of a panic about time in all of these. I've agreed to a thing I don't know how to make, and I have a deadline. And sometimes the deadline is short. That piece Whale with all the big spinning tubes that was at the MIT Museum. I had to put that together in 6 weeks from end to end. It was just me and an intern helping me do the final assembly. So a lot of times this stuff happens in quite a sprint.
Anyway,
Yeah.
so I've been self-employed since 2000, so I understand the limitations and client deadlines. How often do you actually surpass a deadline or budgets? Like, do you actually?
Oh.
Like, what are your percentages?
I don't usually surpass the budget very often. I'm trying to think. It happened in this project in Mexico City for a lot of reasons. That project got very complicated. They wanted me to ship it early before it was finished, and I had to finish outside of my studio. I've learned over and over again, I can't really work well outside of my studio. It's so fast and so easy. I have all the tools I need and I have so many parts, but I spent so much time down in Mexico City running around. Finding things works so differently there. You have to know somebody who knows somebody, and at the back of a store somewhere that sells something unrelated, there's a door and you can go through and there's a guy in a room with a bunch of boxes of stuff, and it's wonderful, but not to an outsider, because I don't have access to all that stuff. I went over budget that time. What I tend instead to do is to end up making very little money on the project. So usually when I go over budget, I don't go back to the client. It cuts into what I'm going to make on it. And in terms of overtime, not very often. It's a good question. I'm always very concerned about this. Sometimes it's immovable. There's a performance, there's a museum opening. Like a lot of times the things I'm doing, there isn't any flexibility in the schedule for it. So the answer is we figure out. Sometimes it's that wonderful thing. This used to happen to me a lot where it's like, oh, this would normally be like a 5-day process, but we need to figure it out in an afternoon. It has to be done before I go to sleep tonight, whenever that's going to be. And you figure out a way to do it. And this would happen over and over again. And I was wondering, is my whole life like this? Am I taking like 20 times longer to do everything than is actually necessary? But I think it's bad for your health because you end up working for 30 hours straight, and I might as well be a chain smoker at that point. Yeah, it is. Well, oh, one more.
I've got one question. So has maybe you've been asked this before too. I've noticed that. So I do my research. I'm at CAMD doing my PhD in creative practice, like human values and philosophy alongside human computer interaction, more specifically with AI. And sometimes when I do interviews, especially for artists who work professionally, if they say are employed and they may or may not want to use AI in their practice, it usually comes from their employers asking them to use the technology. Now, you are self-employed, so I'm asking you as the complete person, have you come across AI in your creative practice in many shapes or forms, or have you used it, or has it permeated your practice? And asking that question because of the context earlier where I notice artists, when they do use it, if whether or not it's for their practice, it comes from things being efficient and those things. And you mentioned time in your studio, so.
Well, I've been using Claude Code sometimes to set up work environments and build environments for software. So I haven't used it to write a lot of things because I don't want to I build so many things myself where I open up all the black boxes and I want to understand how they work. So when I work with ChatGPT or Claude I'll have it write functions and sometimes classes for the software, but I don't want it to write the entire stack because I've learned I have to understand everything, all the details of the project I'm building, because I need to change it and pivot it very quickly. So I think largely it needs to be inside my head. Other than that, I haven't used it for a whole lot. Part of it is because my whole motivations for making work are sort of counter to the idea. I don't want creative ideas or simulated creative ideas or synthesized creative ideas to be coming from outside or from a non-human source, just for my own personal aesthetic reasons. But when it comes to practical things, yeah, absolutely. And at some point, perhaps I'll use it for analog circuit design because I'm really not good at it. And if it helps me, I'd be happy to.
Thanks.
All right. Well, thank you very much.